Okay, in this video, we're going to talk about how to plot position, which we'll call x, versus time. We'll talk about how to plot velocity versus time and how to plot acceleration versus time. Okay, now we're only concerned with the case where acceleration is constant. So let's first look at the set of plots where acceleration is 0 and velocity is 0. Let's start that. Okay, so if both of these things are 0, then we can plot the acceleration. So by the way, it's always best to plot acceleration first because it's always going to be the easiest. Since we're only concerned with acceleration being constant, the acceleration plot will always just be a horizontal line. In this case, it's 0, which means we plot it along the axis here. And this is just telling us at all times, acceleration is 0. Velocity is also 0 at all times, so it has the same plot. Okay, now because the velocity is 0, that means that our position is not changing over time. So it is also a horizontal line, and it's a horizontal line at whatever point the object is staying at. So if it's at 10 meters, then it'll stay at 10 meters. Maybe it's at 0 meters, it could be across the axis, or -1 meters or whatever. Okay, so that is the absolutely simplest case you could have where there is no motion at all. So the next thing that could happen is that acceleration is still 0, but velocity is not 0. Okay, so in this case, acceleration, still easy to plot. It's still 0, so it's still like this. Now, if the acceleration is 0 and the velocity is not 0, then the velocity must be constant. So the velocity must be a horizontal line. And a horizontal line where? It depends on whatever your value for the velocity is. So for instance, maybe it's 1 meter per second. So that would be a horizontal line at 1 meter per second. Maybe it's a horizontal line at -1 meter per second if your velocity is negative, whatever. It's a horizontal line somewhere. Now, how do you plot position if you have a constant velocity? Okay, well, remember our formula for position is like this. So this is our formula for position if acceleration is constant. In this case, acceleration is 0. So our formula for position then just looks like this. And what sort of shape is this? This is a line. Now, if the velocity is positive, then it's an increasing line. So you start the plot at wherever the object is at time 0. Maybe it's at -1 meters. And if the velocity is positive, then it's an increasing line like this. Now, if the velocity were negative, then it would be a decreasing line. So maybe in this case, it starts at 10 meters and it decreases. Okay. So remember also that we can find the velocity from position because the velocity at any point is the slope of the line. We can also see that in our equation here. This is the slope of this line, and that is the velocity. Okay. Now, the other case is that acceleration is not equal to 0. Yeah, so acceleration is not 0. So in this case, acceleration could be positive or negative. So let's suppose that it's positive. Okay. So if it's positive, if you remember our formula for velocity, our kinematic equation looks like this. So if acceleration is not 0, but it is constant, then velocity is linear. And since our acceleration is positive, our velocity is increasing. So it has some initial value of the velocity. Maybe it's 1, or maybe it's 0, or whatever it is. You start there at time 0. Acceleration is positive, so it goes up like this. Now, our equation for x that we just saw for position looks like this. Okay, so it has a dependence on t squared, which means that position, if there is acceleration, is parabolic. Okay, it's a parabola. So if acceleration is positive, it's open like this. This is a parabola. This is what it looks like. If acceleration was negative, then it would be downward facing like this. But okay, whatever. So here, we want to draw this. It starts at positive and it just keeps increasing. So we're only interested in the part of this parabola that keeps going up. So maybe something like this. If it starts at this point, maybe it starts at 1 meter, whatever. Okay. Now the other part of the parabola maybe looks like this, but we don't care about this part because it's before time 0. So we only draw the part of the parabola that we're interested in. Okay. Now another case is that acceleration is still positive. So it's still a horizontal line somewhere up here, but the velocity is initially negative. Okay. It's still increasing because acceleration is positive, but it's initially below the axis. Okay. So in this case, there's an important point here, which is this point. At this point, the object is stopped because the velocity is 0 here. Okay. Now we can plot position. Okay. Now it started off negative, which means the position plot should initially be getting more, should be decreasing. So maybe it looks something like this if it initially starts at this point. Okay. So this is the part of the parabola that we're interested in here. And notice at this part, if we drew the tangent line here, it would be a horizontal line of slope 0. So remember, the slope at any point on a position graph is the velocity. So this point here lines up with this point. So this is the point, that moment where the object is stopped. So it's also the moment where it turns around. So this, for instance, could be, I don't know, a car that has its reverse engines going. So it's initially going in one direction, but then the reverse takes over, it stops, and it starts going the other direction. Okay. So the other case is that the acceleration is negative. So if the acceleration is negative, but still constant, then it's a horizontal line below the axis. So in this case, the velocity is still a line, but it should be decreasing. So maybe it looks something like this. Okay. So we can plot position then. So position will be a parabola. It'll be downward facing since the acceleration is negative. And we know that there's some point where the object is stopped. So at the time where it's stopped, we should have that part of the parabola that where it evens off. So this looks something like this. Okay, so where this point, this is where the object is stopped, is at the same time as this. Okay, so this could be something like you threw a ball up in the air. So the ball keeps going up, 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 up. It stops at this point, and its velocity is 0 at this point. Then it starts falling down, and its velocity starts to become negative. But the whole time it's in the air, its acceleration would be the acceleration due to gravity. So negative 9.81. All right, so the only other case is where the acceleration is negative. And the velocity starts off negative. So instead of starting up here and coming down, we just have this part of the velocity. So in this case, nowhere is the velocity 0. So when we draw position, we shouldn't have that point where the slope is 0. So maybe it looks something like this if it starts at positive. Okay, so the only other thing that we could have are combinations of these. So for instance, we could have a car that moves at a constant 1 meter per second, say for 10 seconds, then it stops for 10 seconds. And then it moves at -1 meters per second for 10 seconds, okay? And let's say we want to draw the velocity graph for this. Well, let's draw acceleration first. Well, the acceleration, so we're interested in 10 seconds. So here's the first 10 seconds. Here's the second 10 seconds. Here's the third 10 seconds. Well, for the first 10 seconds, it's moving at a constant velocity, which means that the acceleration is 0. For the next 10 seconds, it stops. So the acceleration is still 0. And for the last 10 seconds, it's still moving at a constant velocity. So the acceleration is 0. Okay, easy enough. Now let's draw the velocity. Okay, now the velocity is constant. Here's our 10 seconds, 20 seconds, 30 seconds. It's constant at 1 meter per second for the first 10 seconds. So it's a horizontal line here. Okay. Now for the next 10 seconds, it's stopped, which means that the velocity is 0. So it's down here like this. And then for the next 10 seconds, its velocity is a constant -1 meters per second. So it's down here. Okay. So there's our velocity. And now for position, let's just assume it starts from the origin. Okay. Here's our 10 seconds. Here's our 20 seconds. And here's our 30 seconds. Now it's moving with a positive velocity for the first 10 seconds. And it's at a constant velocity. So that means our position should be linear and it should be increasing, which means it looks something like this. It is linear with a positive slope up to 10 seconds. And then it's stopped for 10 seconds, which means that the position will be a horizontal line. And then it has a negative constant velocity, which means it'll be decreasing in linear. So it looks something like this. It goes back down to where it was because of the symmetry of the problem. It's going up +1 meter per second for 10 seconds and then -1 meter per second for 10 seconds. So it gets back to where it was. But if this had been like a different value, like -2 or whatever, it would have gone below the axis. Okay, so this is pretty much all there is with these plots. You only have these particular cases with constant acceleration. And then the only curveball that I could give you is if we have different segments of the motion. But you just treat each segment independently and do the same thing. Okay.